Hey there, and welcome to How To Videos with Dr. Amy Gates. This video is going to show you how to take a data set that's a little bit disorganized, convert it into a pivot table or place it in a pivot table area so that you can organize the data and look at the data the way that you want to see it, and then use the data from a pivot table to run a one-way ANOVA with a post hoc analysis done in t-tests. So kind of a slightly long process here, but very often you'll find that you just have a data set. And the way that data set is organized is fine for some cases, but is, say, for example, not convenient if you want to run a one-way ANOVA. So in this particular example, I have the number of hours that students have spent studying for the week, and I also have the score that they got on their project. And if you'll notice here, there's a finite number of possible hour choices. The student might have spent 1 hour per week, 3 hours, 5, 7, 9, or 11. So 6 different options or groupings. And then these are all the project scores. Now I'm suspicious that there is a significant difference, statistical difference, between the project scores for students spending a different number of hours studying per week. And so I'd like to run a one-way ANOVA because I have one dependent variable that I'm looking at, which is the project score. And I have 6 different groupings, and I want to compare those groupings to see if there is a statistically significant difference. Now the way this data set is set up is very inconvenient, because in order to run an ANOVA test here, what I need is all the students' project scores who studied for 1 hour, so that would be this one and this one and this one and this one, so on. And then I need all the students' project scores who studied for 3 hours, and so on. So one of the fast ways to do this, and of course there are many, but one of them is to use a pivot table to reorganize the data, and then use that reorganized data to run the ANOVA. So that's what we're going to do here. In order to convert this data into a pivot table, I'm going to go to Insert, Pivot Table, and then if my data is set up nicely, which mine happens to be, all of my fields are noted, I don't have any blank data cells, I don't have any extra columns I'm not using, and so on, and there's nothing else in my worksheet, Excel automatically knows that this is where my data is, and it outlines it for me. So it says my data starts at A1 and goes all the way to H36, which is correct. Now, if for some reason it doesn't outline your data, or you want to just select a portion of your data, you can do that. So you want to select the data that you want to then place or have access to in your pivot table. Now I want all the data, so I'm going to start over here, and I'm just going to choose my pivot table and let Excel grab all the data for me. I also want to place the pivot table in a new worksheet, so I'm going to select this option and I'm going to click OK. Once I'm here, I have kind of a blank slate and I have all of the fields or columns from my original data. And this is in a new worksheet that I can access here at the bottom of my Excel document. So here's my original data, and here's my pivot table area. Here's all the fields from my data. And here are all the goodies that I can use to organize or reorganize that data, just choosing the fields I want to look at and maybe putting them in a table form that is more useful for me to run an ANOVA test. So remember we said that we wanted to look at the number of hours a student spends studying with respect to their project scores. So these are the 2 fields that we're really interested in. And when I first click them, the default is Excel will put them here in the sums area, will sum up all the hours and sum up all the project scores and create this little mini pivot table for me. Now this is not at all what I'm looking for. What I'm actually looking for is I want to group all of my project values by the number of hours the student studies. And I can group those, and I'm going to move this out of the way and start over. I'm going to group those by column or row. That's the decision I can make. Truth is, both works. I prefer rows. So I'm going to take all of the different hours spent. I'm going to pull it down into the rows area. This is a good start because now it's creating categories or rows that are distinguished by the number of hours the student spent. So this is a student who spent 1 hour studying. This is a student who spent 11 hours studying. But now I want to fill this in with the score they got on their project. Now there's a lot of different project scores and a few ways to do this, but I want to see all the data. I don't just want it summed up or averaged. So the way I'm going to make the pivot table do that is I'm going to take the project score and put it in the columns area. So this is all the possible project scores that happen to be here in this area. But I want it populated with data according to the number of hours spent. And in order to get it to do that, I need to take the project and I need to put it in the values area. But I don't want it summed up. I'm just looking for an average at the end. So I choose Value Field Settings and I select Average and click OK. And what this does is it says, okay, all the students who studied for 1 hour, these are their project scores. And this is the average for them. All the students who studied for 3 hours, these are their project scores, and this is the average for that group, and so on. So by using a pivot table, I can create rows that represent my groups or the populations that I'm trying to compare using a one-way ANOVA. So now I have the data in a setup that will be easy to use for a one-way ANOVA, and I can just take the next step right here in this area and run that one-way ANOVA using my data analysis tool. So I'm going to click anywhere blank, and when I do that, notice that the pivot table goodies disappear. If I want them back for any reason, I click anywhere in the pivot table and they come back. But let's click outside here. And let's choose Data, and then Data Analysis. I'm looking to do a one-way ANOVA because I have one dependent variable, which is the project score. And I have 6 different groups that I want to compare. So that's a single factor ANOVA or a one-way ANOVA. I click OK. And now I need to tell Excel where my data is. And Excel's relatively clever, which is nice because notice that it's already highlighted just the data that I need. It didn't include the total or the averages over here, which is good. And it has also the labels of each of my categories. So I want to make sure that the box is checked here that says labels in first column. And I also want to make sure that the option of rows is selected rather than columns, because notice that I'm categorizing by row. Row 1 is everyone who studied for 1 hour, row 3 is everyone who studied for 3 hours, and so on. So by rows, the labels are there, and I'm going to go ahead and just put my output right over here. So in order to do that, I can just check, I can delete this or I can leave it, but if you click in this area and choose any empty slot, that's where the upper left-hand corner of your results will appear. You don't have to know the exact size. Now I'm going to click OK. And when I do this, it creates the ANOVA result for me. But because these cells are so tiny, I can't really read much of what it says. So what I like to do is once it creates this for me, I like to grab it, so highlight it with my mouse, copy it by hitting Control-C, open up a new area in Excel, and then hit Control-V. And that places the results for my ANOVA test into a new worksheet in Excel. Now I want to see the result of my ANOVA test. And I'm looking for the between groups interaction because I'm comparing those 6 groups. Here are the groups, by the way. All 6 of them are listed here. And these are the students, again, that studied for 1 hour, students who studied for 11 hours, and all of their averages for their projects. And you can see visually that students who studied more are clearly getting higher grades on average. But is this statistically significant? The answer is yes. So the p-value, or the result of this ANOVA test, is 1.4 to the -6, which is essentially very close to 0. Now we know that our test is significant if our p-value is less than our alpha value. Most people choose an alpha value of 0.05, which is fine here. And of course, you can choose a smaller value if you want a stricter test. This is also a between groups test, so we're comparing all 6 groups. So what do we have so far? We know that our p-value is essentially 0, and we know that 0 is less than our alpha value of 0.05. So far we know that we do have a significant result here. It's absolutely the case that the project averages are significantly different between these groups. But what we don't know is which groups are specifically different. Is 1 different from 3? Is 1 different from 9? Is 5 different from 7? And so on. In other words, because we have a significant result, which we do, the next step in an ANOVA test is to run a post hoc. Now, Excel doesn't necessarily have a beautiful post hoc that you can just click a button and it'll run it. What you have to do instead is you have to run a t-test on any 2 groups for which you are curious if they're significantly different. And what I might want to do is I can see for sure that, say, group 1 and group 11, these are definitely different. I've got a significant result. I can make that conclusion comfortably. What I can't be sure of is group 1 and group 3. So the next thing I can do is run a t-test just on those 2 groups to see if they happen to be significantly different. So I can go back to my pivot table area, and let's scroll back up to where that was. And I can click on any blank area. I can choose data analysis, and I can scroll down here and choose to run a t-test. And I'm going to assume equal variances because I know that project scores tend to have similar ranges or variations. So I'm familiar with this data enough to be comfortable with that choice. If you're not sure, you can always run an f-test, but that's a whole nother lecture. So we're going to run a t-test with equal variances. I'll click OK. And what I'm looking for is to compare 1, which it's already selected for me because it's smart. And I want to compare this with 3. So let me go ahead and make that selection all the way to the end. So that's group 1 and group 3. I do have labels. And I think I'm going to go ahead and put my output right there. Just starting in that spot, I'm going to click OK. And there's the result of the t-test. And I can read this result pretty well, but just like in the other case, I can cut it out of here if I want, Control-C. I can create a new Excel spreadsheet down here at the bottom. Control-V pastes it in. And then I can take a closer look at the responses and spread out the cells a little bit more. All right, so what's my result here? I want to look for my p-value. Here is my p-value for this particular test as a 1-tail. Here is my p-value as a 2-tail. In both cases, I do not have a significant difference. And we kind of suspected that, which is why we ran this test. So in this particular case, even though my ANOVA test is significant overall because some of those groups are significantly different, not all of them are. And to determine which groups are specifically different, you would want to run a t-test on any 2 groups that you wanted to further evaluate. And then check out the p-value for that result. So to briefly review, we started out with a big data set. We went ahead and used a pivot table to clean it up a little bit and to choose the values that we were comfortable with. And here's our pivot table up here and all of our pivot options. And then from this area, we were able to use the data and data analysis tool to run our one-way ANOVA. And then to run our post hoc, we used the t-test. Thank you for joining me for this how-to video, and keep a lookout for more how-to videos on Excel.